Okay, under in the confidence interval, now we are discussing going up from last video. The confidence is in the method, not in any interval. The confidence is in the method, not in any interval. Any value inside the interval, any value inside the interval would be said to be plausible value. CA, confidence interval, are twice the margin of error. Twice the margin of error, and provide both a measure of location and precision. And provide both a measure of location and precision. Three things affect the width of a confidence interval. Three things affect width of a confidence interval. Confidence level usually 95%. So 5% and not 100%. Then variability. If there is more variation, more variation in the population, each sample taken will fluctuate more and wider the confidence interval. The variability of the population is estimated using the standard deviation from the sample size. Without lowering the confidence level, the sample size can control width of confidence interval. Width of confidence interval. Width of confidence interval having a inverse square root relationship to it. Sample size without lowering confidence level, sample size can control width of confidence interval having an inverse square root of relationship to it. CA for completion rate binary data. CA rate is one of the most fundamental usability metrics. Completion rate is the one of the usability metrics defining whether a user can be complete task. Usually binary response 0 1 binary response. The first method to estimate binary success rates is given by world interval. What he is mentioning, where P cap is the sample proportion. N is the sample size. sample size. Z of 1 minus alpha by 2 is the critical value from the normal distribution for the level of confidence. Here, sample proportion. Sample, this is the sample. Sorry. Sample, for example, sample proportion, n is the sample size. Z of 1 minus alpha by 2 critical value from the normal distribution for the level of confidence. Sample proportion plus or minus Z sample proportion how much we have got, then alpha divided by 2. After getting this we have to subtract from one value, then we have to multiply with Z. Okay, so alpha here need alpha Z need. Then sample proportion into, we have to that same proportion, sample proportion to be minus from 1, then divide by a number of n is the sample size. Sample size how much? This is the n is the sample size. Okay, and divided by the sample size, then how much we are getting? We have to square root. Then we will get the square root means what? If we are squaring 4, then we will get 2. 16, 4. So it means how much we are squaring, that is square rooting, that much multiplication reducing. So here reducing the value, then you have to multiply to this with this multiplication. Then plus or minus with that proportion. So valid interval, which is now, then this is called valid interval we find. Okay, very inaccurate for small sample sizes. Very inaccurate small sample size, less than 100, or proportion closer to these are one. Very inaccurate small sample size. Small sample size less than 100. Less than 100. Otherwise we can say, okay, there are like this. Okay, no problem. So proportions close to 0, here 1. Okay, 0 or 1. Okay. For 95%, Z equal to 1.96 confidence intervals, we can add two and 2 failures to the observed number success and failures. Okay, then where x is the number that is successfully completed the task, number that successfully completed the task, and n number, nth number who attempted the task sample size, that is population, sample proportion, pk cap is the sample proportion equal to x z square. How much we are getting, we have to square it, then divide by 2, then we have to add like this, divide by sample size plus square. How much these we are getting, we will average this one. I am correct now? Divide. So equal to x plus x plus 1.96 square by 2 is equal to 1.96. So here also n plus what? Z square 1.96 square. So approximately x plus 2, here n plus 4. Okay. C for task time data. C for task time data. Measuring time on task. This is task. So measuring time here is a good way to assess task performance. Task and tend to be possibility skewed, a non-symmetrical distribution, so that mean is not a good measure of the center of the distribution. In this case, the median is better measure of the center. However, there is a major drawback to the median: variability and bias. Variability and bias. Median is the better measure of the center. However, there is two major drawbacks to the median: variability bias. Variability bias. Then the median does not use all the information available in sample. So consequently, the medians of samples from continuous distribution are more variable than their means. The increased variability of the median relative to the mean is amplified when the sample sizes are small. The increased variability of the median relative to the mean is amplified when the sample size are small.